Hey, this is James Diamond with GlockCNC, and I wanted to make a video update because, as you know, sometimes I just don't want to type one. So, this is the video update for November. I thought I had made an update in October, but it looks like I didn't now that I look at the screen. Anyway, here's your update. We'll start out with the BT30s. Those who have some BT30s, we have the spindles here. This man, the supplier that we're using for these now, they did an amazing job on the outside surface area of the spindle. But when I went to go put these together, I noticed that they had forgotten to send this out to get the inside of this ground, and they did a nice enough job on these surfaces that they didn't need to be ground, and I'm okay with that. That's perfectly fine, but the inside has to be ground to get the right amount of accuracy out of that and the right surface finish. So it took them a little while to find a grinding shop that would do these at a reasonable price. Grinding is very expensive. That would fit within what they quoted us. And then it took us a while to get in line at a grinding shop to get these done. And we're getting these sent back to us as they get some done. They're sending them back to us. And that grinding shop that they ended up using, a pretty busy shop, and so they're doing chunks of them at a time for us and then getting them sent out. So I have some of these now currently, and I'll be getting some of those all sent out, and as they send us more, I'll be just getting these sent out. If you have the R8 or 5C, as you probably noted from one of the updates that I did put on the website, that some of them, actually almost all of them that we got in, and this is the way would have them error to the side of putting too much material on the bearing races. I don't have a 5C or R8 in hand here, so I'll just use this as an example. Where the bearings fit on there, they're slightly oversized, and we have to have those actually at just the right amount of size. And so we decided what we're going to do is we're going to lap those. There's a company right here in Michigan that makes laps, internal laps. And all that really is, it's a material, brass is the material these laps are made out of, that kind of clamps around this, and there is lapping compound. It's just abrasive in a kind of a slurry that goes in there, and as we rotate this part, it takes a small amount off from this and actually makes it a lot more round. Now there's two advantages. I know we're only taking off a tenth or maybe 2/10 off from this, and it doesn't seem like much, but actually it is a tremendous amount when it comes to, well, I shouldn't say tremendous amount. It's an amount that genuinely makes a difference. How about I put it that way? When you have too much on here, too much material on here, and the diameter is too large, and you shrink fit a bearing on there, there's two effects to that. Number one is that it ends up pushing on the outside of the inner race of the bearing, and that puts preload in the bearing, and then that can have other systemic effects. They can end up causing more heat and premature wear and so on. But the other side of that equation is that when you have an oversized diameter and you shrink fit the inside race of that bearing, then the inside race of that bearing now conforms to whatever this shape is. And that might end up adding, depending on how you orientate it in there, if there's any amount of, let's say, error in the inside race of the bearing, and there's going to be a certain, whatever error on this, and if you put them on the same spot, now you have error stacking. So it's just not an optimal thing. You want these surfaces, when you're doing spindles, high precision things, you want the diameters to really be just right on these. So that has been a new skill that I had to learn. While it in itself is not that complex, it does involve a little bit of trial and error to get it right, and the setup and how to set this up to spin this to start doing the lapping. So that is something we've had to do to the 5Cs and the R8s. And anymore, and you may have noticed this from some of my other videos, it just seems like for the past 3 years or so, any part orders that we get in, and I'm talking whether it's something I source internationally, maybe out of Asia, or it's something that we're getting done here domestically, the parts seem to have something on them that we have to tweak or correct, whether it's the size of a keyway hole or just whatever it is, something needs to be corrected on it, and I'd rather have them err to the side if it's leaving more material on than not. But that seems to be just the nature of the beast now, and I can't help but think that, again, maybe it's just, as I've maybe mentioned before in a video, it's maybe a labor shortage issue, and they're having to use new people who just don't have the experience yet, or or some reason quality control checks have been going down. I don't know, but it's kind of a time-consuming thing to have to finish products or kind of do tweaks to products after we get them back in. But it's just the way it is at this point. So let's talk about the motors. Those who have motor orders and those who have spindle orders that include a motor. I'm making more mounts, motor mounts. I've run out of motor mounts. I made a production run of them a while ago. I'll be dedicating a good chunk of next week toward making more of those motor mounts. And this is my fault. What I ended up doing, the last batch of motor mounts that I made, and I don't know why I did this, but for some reason there is a row of holes that I end up drilling, then tapping as part of one of these L brackets in the mount. I made them, I don't know how I did this, but I made that row too narrow. Those holes were in the wrong spot, and I didn't notice it until I had gotten them all but finished. And I'm like, oh no, man, I made those in the wrong spot. So, yeah, I noticed it part we were doing, so I still made a bunch of them correct, but I had a bunch of them I made incorrectly. But what are you going to do? So I'm making more of those next week, so I can get those orders out, the individual motor orders, as well as some of the combination of headstock and motor orders. The other thing, too, as you can see on the screen, we have introduced the BT30 adapter for Precision Matthews PM25, Grizzly GO704s, BF20, 25 mils. They're all kind of the same thing. And the reason that we've ended up doing that is not for the sake of adding more products to the lineup, because I still, I'd like to be caught up to the point where the orders go out within, days instead of, weeks. But what we've done is we've bought individual benchtop machines to handle one or two, at most maybe 3 different parts. So they're dedicated, and we don't have to do a complete pull out, a setup on a machine, make a part, and then re-pull that out, do a new setup on it, because I want setups to be in there and fixed in place so that it reduces the chance of errors, because every time you've got to do a new setup, you introduce new chance for error, and machine setup and tramming in, that's all very time consuming stuff. So I have 3 different machines, actually 4 different machines, benchtop machines, that are making just a few parts. One of them we decided we would use because of its compact size, but a good table size on it for its work envelope, is the Grizzly GO407, and we wanted to use our BT30 on it since it is just a whole world better than the 5C, or not the 5C, the R8 that comes on there, and the motor that comes on there. So as you can see, what we've done is we've created a mount for fitting that onto there, and that mount does rotate. So that's kind of a cool thing, and it just uses, again, the headstock that we already produced. It's not really adding that much more to our lineup as far as parts. It's just a 2-part adapter. So there's that. And also, as part of our new production runs here in-house, we're trying to get as much of our parts made here in-house. We are going to 5-axis, and the 5-axis parts specifically are going to be the headstock. That's the one that we're doing most of the 5-axis work on. And the reason that we're going into 5-axis is because each time, if you have to pull out and rotate a part to do a new feature on it, each time you pull it out and you reposition it back in there, it's just introducing a greater chance for me or whoever I have running the machine at the time, let's say, to make a mistake. And if I've got somebody in there that I've just trained, I've had somebody that I'm working with who's helping me out here in the shop. I can't get them in here as often as I want, but it's easier for them if they can just load the piece in there once and have it do as many of the features as possible, and 5-axis makes that happen. And what we're doing is, it's very simple, and we'll release this so that you can have a 5-axis machine as well. The GO704 will be the first one, then we'll have the PM30 size mill and the TAG, and probably last will be the Shoreline, because that's going to use a little bit different setup. Really simple. All we're doing is, because of the compact size of our BT30 headstock, is we're just using a 6-inch rotary table, and we have a mount that just puts a stepper or servo on there if you're going to do a servo, preferably a servo with a brake, or just a closed loop feedback stepper does an excellent job on that. So it'll be a rotary head. So this head portion right here will, well, that kind of magnified it. This will rotate, and then we'll have another servo driven or stepper driven, in my case initially at least, on the table itself that will rotate. So we'll have a 5-axis setup. It'll be simultaneous. And one of the cool things about this is that we'll be introducing a few of other companies' products to show you, so that you can see kind of the least expensive 5-axis setup. Kind of, we might be able to show you mid-range if Mazo can send us a controller to test out. But in fact, let me just show you. The one we'll be using to show you on the least expensive end of it will be the Ethernet Smooth Stepper by Warp 9, as shown right here. And that you can either use a Mach 3 or Mach 4 on, very inexpensive unless you decide to upgrade to the Mach 4 industrial version. And there actually is a reason why somebody might want to do that. But the Maso one would be kind of like the intermediate step one. I've not used any of their products. I'd really like to use their products. I've reached out to them. I haven't heard back about them sending us one of their controllers so we can demo it and show it. In fact, if you want, go ahead and email Mazo and say, hey, GlockCNC would like to demo one of yours in their 5-axis machine. But the top tier one, and this is a product I'm pretty excited about because I have been really wanting this, is the new Acorn. The new Acorn 6 is their new product from Centroid. In our shop, what I personally use is we retrofit. I have some machines that use that smooth stepper, but the more common one we use in their shop is the Centroid Acorn. But for a long time, until now, it's only been 4-axis, which is fine for a lot of things, but I really needed the 5-axis because I wanted to introduce a 5-axis into our shop as well as to our customers. And now they have a 6-axis control board, and it's got just a ton of features in it, a whole world, a big step up from all the other controllers out there. This really is more in the industrial commercial arena, and one of the reasons is because it will now also take encoder feedback, whether that's a rotary or a linear. As you can see right here, it's got plugs for it, so you can use this as a DRO. But not only can it be used as a DRO, but it can be used to feed into, so that the actual controller knows the position of the mill. And so let's say if normally it would make an undersized cut, maybe it gets to the end of that and it'll realize it's made an undersized cut. It will make the additional little cut tweak as needed to make the thing accurate, whatever you're cutting. In addition to that, there's just tons of other relays and things you can put on there. I mean, it's really a step up. Pricing wise, I'm not going to go over this, take too long on this, but pricing wise, it's not cheap. This is about $1,000. The Acorn is normally $349, and the software is about the same price, pretty close anyway, a little more expensive than the software for the Acorn. The big thing though that is kind of expensive if you want to use the full 5-axis is the 6-axis simultaneous interpolation. Software is not that cheap. It's a grand. So this would be the top end commercial grade end of it if you want to go down that route. This way, I've talked with the owner's son there. We'll be getting one of these in a little while. As far as introduction rate, it's going to be not until the second quarter of 2023 because, again, I really need to get further caught up on some of my current orders before even though we'll be using the actual product itself, I want to get caught up before I actually introduce this into the wild for customers to buy. So, well, that went in a little longer than I thought I would, but there you go. There is the latest and greatest.